Hello students, welcome back to Turito's live classes. So students, we have started with the chapter known as what matter in our surroundings, correct? So we have entered in the next session of this chapter where we are going to discuss about new concepts such as evaporation and boiling. But before we jump into these topics, it's time to revise whatever we have covered in the last class, correct? So in the last session, we were discussing about interconversion of matter, correct? So here what we have studied that we can convert one state of matter into other, such as if I am having solid particles, okay, so solid state, this is the state of matter which can get converted into liquid, correct? This liquid can get converted into the next state, that is what? Gas or vapors, okay. So students, how do we do that? When we supply heat to solid particles, they can get converted into liquids. Liquids on further heating can get shift into gaseous particles, right? So basically this is nothing but we are converting these different states of matter. So this is also known as what? Interconversion of matter, alright. So we have seen like how this interconversion of states is happening. So there are some phenomena or some properties with the help of which we can understand this interconversion of matter. We have talked about fusion and solidification. Can anyone tell me what do you mean by fusion and solidification? Okay, so what did we discuss in the last class while we studied about the fusion? Anyone? Okay, so here I'll just revise. Fusion, okay, suppose I am having a matter which has the state solid, okay, this is solid state, or if I am going to supply some heat to the solid particles. We know that solid particles are very compact, or they are they are very closely packed, correct? So if you are going to supply some heat, some external heat source, if there, definitely something is going to change. That is what kinetic energy of the system is going to get increased. Okay, kinetic energy of the system is going to get increased, or if I want to zoom this, I can show you there are some kind of force of attraction, right? That is what we have said, interparticulate force of attraction, or I'm just going to write intermolecular force of attraction. Interparticulate force of attraction, correct? So here what happens, students, when you are going to supply some heat to these molecules or to these particles, the force of attraction is going to get decreased. Okay, now these particles are going to feel less force of attraction. Okay, so that interparticular force of attraction is going to get decreased because we are going to fuse the bonds. We are going to break down the bonds among these particles by supplying the heat. And we have seen that the kinetic energy of these molecules is getting increased, and that's why these particles are moving away from each other. Okay, if this is happening, what do we observe? We observe that the spaces, the interparticular spaces are going to get what? Increase. The force of attraction is going to decrease. Okay, there is a fusion of these bonds basically, and that's why the spaces are going to get increased. Students, if there are some intermolecular spaces, tell me after solid which states of matter has this property? Like there are some spaces. Of course, liquid, right? So what you have done, you have actually transformed or converted solids into what? Liquids. How? By fusing the bonds, or by decreasing the force of attraction which is present in these solids. Okay, that's how we define what? Fusion. Basically, you have supplied external heat and you have melted those solid particles. Now whatever we have, it is in molten form or it's in liquid form basically. Okay, so that's how we can say it's a fusion process or fusion phenomena which we have seen. Now solidification is it's in opposite to fusion. What if I am going to cool down these liquid particles? okay, their kinetic energy is going to get decrease, and these particles are going to get, like they are going to get bonded, or they are going to come closer to each other, and that's why they can get solidify from liquid to solid, right? So that's why the name is what? Solidification. All right. Then vaporization. If I am having liquid and liquid consider, instead of solid we are taking liquid molecules here, and if we are going to supply heat, these molecules are getting extra charge, extra activated, and that's why they are going to transform themselves from one state to other, like from liquid to vapors. Vaporization is nothing but formation of vapors, and when you are going to cool down these vapors, they are going to get back to liquids. Interconversion is happening, and the phenomena is what? Condensation. Okay, so we have seen condensation happening when you are taking out the cold water bottle from your refrigerator. After some time you have seen there are some droplets. Okay, this is a bottle and there are some droplets on the outer side of the bottle because there is the difference in the temperature. Okay, now the air molecules which this bottle is surrounded by, they are experiencing less temperature. Basically we have cooled them down, and that's why from vapor or from gaseous state they have transformed themselves into liquid molecules. All right, let's move ahead. We are having sublimation. So there are some substances, they can directly transform themselves from solids to what? Gaseous substances. Okay, there are some substances they can directly transform themselves from solids to gaseous substances. So this phenomena has a specific name, which is nothing but what? Sublimation. If I want to take example, I can tell you that we are having substance called as what? Or salt is nothing but what? Ammonium chloride. Okay, this is solid in state. Okay, what is like physical state is solid. This is a salt. Okay, and after, if you are going to supply heat, we observe that we are going to get vapors of ammonium chloride. Okay, so this substance is going to get sublime. So it is not transforming itself from solid to liquid. No, this sequence is not getting followed. So it is directly going it is going to get transformed into gaseous states. All right. So I can say that ammonium chloride is it is showing sublimation. Okay, naphthalene balls, camphor, these are few examples of what? Sublimation. Correct. Students, we are having next concept, that is what? Deposition, or also we can refer this as desublimation. What happens? It's opposite to sublimation, right? How? If these vapors or gaseous particles are they are going to get cooled down, deposition of these vapors happens and they are back to what? Solid particles. Earlier you have taken camphor or naphthalene or ammonium chloride and you have supplied the heat to them. Those particles are getting heated, right? And now they are directly jumping in the gaseous state. Now when you are going to cool down these vapors, they are going to get deposited, okay, or they are going to get desublime, because of which they are coming back to solid particles or solid state of matter. Got it? That is what? Deposition or desublimation. I hope you all are able to recall these concepts which we have learned in the previous class. All right. Then we have talked about the liquefaction of gas. So we can liquefy or we can convert gas into liquid state by applying high pressure, and we have learned about that too. Is that all clear with you all? All right, let's move ahead and see what we have in today's session. So in today's session, we are going to learn about many concepts such as what? Evaporation. It's very, very important. You can mark it as very, very, very important topic from chemistry point of view. Okay. So evaporation, then next to that we have factors affecting to evaporation. Then moving ahead, we have next phenomena called as boiling, then melting point. Then these are very important. I am writing here latent heat of fusion. Then we have boiling point, latent heat of vaporization, and lastly we are going to deal with what? Freezing point. Okay. So grab your notebook and pen and let's get started. So let's talk about the phenomena called as what? Evaporation. What is this? Evaporation. So students, if I'm asking you, take a bowl, okay. I'm asking you to do this experiment and add 1 glass of water in this bowl, okay, and keep this water under sunlight for few hours, okay. It's a little activity you can do, you can observe this, you must have observed it too, okay. We are going to cover the daily life application of evaporation, but before that, let's complete this activity. Here I am asking you to take a bowl and add some water in it, and after few hours, what do you observe? After few hours, what do you observe? Is there the water level is getting decreased? What do you think? If this is a bowl, definitely some water is going to get what? It is going to get vanished from the bowl, okay. So these are water molecules, right, which are in liquid state, correct. So these are all water molecules, layer of molecules I have drawn here, and after some time you see like the level of the water is getting decreased. How did this happen? Can anyone tell me? What is the reason behind it? Your answer is nothing but what? Evaporation had happened. Evaporation of these water molecules had happened, and that's why we see there is reduction in the level of the water molecule, okay, before and after. So students, now it's time to understand like what this evaporation and how does it take place, okay, and where this water went. So let's try to understand this with the help of one proper definition, okay. So at the surface of a liquid, the liquid particles and air particles collide with each other, okay. We have taken a bowl, it has a surface, so such as like this. Suppose I want to draw it again. So this is what is its surface, this is the water level. So these are some molecules, okay. This is the topmost layer of these molecules which is in contact with the air, right, it's surrounded by air. So at the surface of liquid, the liquid particles and air particles collide with each other. Definitely there are some air, and this is nothing but water molecules. These are air molecules, they are going to collide with each other. Now what happens here? During the collisions, energy of liquid particles increases. During the collision, energy of these liquid particles is going to increase, and they escape from the surface and convert themselves into what? Vapors, okay. So like they are going to get escape, they won't be here after the escaping, okay. That's why we say they are what? They are volatile, or they get volatile, or they are forming what? Vapors. They are forming vapors, they are getting escape out from the surface of the water which we have taken in the bowl, okay. And it happened very spontaneously, okay. We did not supply any heat to the bowl, right? We don't, correct, we didn't, right? So here we haven't supplied some heat, but still there is collision which is happening in the air molecules and the water molecules, and these water molecules has got volatile, they have transformed themselves from liquid state into what? Gaseous state. Students, this phenomena is nothing but what? Evaporation. It is what? Evaporation. It is a surface phenomena. What do you mean by surface phenomena? Just now I have told you the surface particles. Suppose, imagine this is nothing but the arrangement of the water molecules inside a bowl, alright, and there are so many molecules in these layers, correct? So they are arranged in a proper way, and only first surface or first layer is getting exposed in the sunlight, correct? So definitely because of the interaction of air molecules with the water molecules, they are going to get vanish from the first or surface layer. After some time we don't see this layer, there won't be the presence of this layer. Definitely all the water molecules from the surface of the this layer they have got what? Vanish. Now what do you think? Suppose this is 1, 2, 3, 4 and 5. This fifth layer is vanished. So tell me, which is the next surface layer? Of course, fourth. Now the fourth layer is getting exposed, or it is under sunlight, correct? So it is now its turn to get vaporized, its turn to get evaporate. So this happens again, okay, this surface is getting evaporated, and likewise slowly, stepwise, each and every layer is going to get what? Evaporated. Okay, the particles or the molecules which are present there, they are going to get evaporated one by one. Okay, so that's how we are saying it's a surface phenomenon. Okay, so this is what evaporation for you all students. I hope you all are able to get it. Let's move ahead. So here, yeah, I have just kept this image. Students, we learn about what? Water cycle. And evaporation is very, very, very important to make water cycle happen, as it is the first process among the various processes of water cycle. The very first is what? Evaporation. What happens in evaporation? I mean, what happens in a water cycle? Students, this is nothing but sea or any water body, correct? These are plants. I hope you all are able to see them clearly. So when we are having sunlight, or they are exposed to sunlight, what happens? The molecules which are present inside this matter, okay, they get heat up, they get extra charge because of the heat, and this is happening very spontaneously, and these liquid molecules or water molecules are getting what? Evaporated, or they are getting volatile. They are leaving their space, space from the surface of the water system, or surface of the matter, in short, be it water, be it leaf, etc. So this is very, very important in water cycle. This is the first step which happens, like each and every water molecule gets evaporated, and then they get condensed, then precipitation, then like these are some processes happens, right? And then eventually we get water or rain, correct? So that's how it plays very major role in our life. Evaporation plays very important role in our life. I have a small question, students. If I am asking, this is a leaf, right? Just now we have seen that from plant also water is getting what? Evaporated. Can anyone tell me, do we have any certain or any other name for this evaporation of water from the surface of the leaf, students? Can anyone tell me? I'm sure you all must have learned about it, right? Okay, let me help you here. So we have the process known as what? Transpiration. Can you all recall it? So it has a specific name. Transpiration is nothing but evaporation, or the water molecules which are present on the surface of the leaf, they are getting what? Evaporated. They are getting volatile. All right. So I hope you all have got this. Let's move ahead. So here, where do we observe evaporation? Okay, so what happens in evaporation? We just have covered about it, like the liquid or the water, it is going to get what? Volatile naturally, and the transformation happens from the liquid state of matter to gaseous state. Okay, this is happening very naturally, it is happening very spontaneously, and it's a surface phenomenon. We are going to understand differentiate between evaporation and boiling, because boiling is a bulk phenomena. Okay, we are going to compare between them soon. Let's focus here. There are some examples of evaporation, such as what? Liquid kept in open vessel. So I have given you an example. So we took a bowl and we kept it for hours, and we observed that there is a decrease in the water level because the water molecules which were present on the surface, they have evaporated. They got evaporated, correct? So next is the hot milk tea is easy to sip from saucer rather than cup. Okay, I am sure, have you all tried this? Instead of drinking cup, drinking tea from cup, if you are going to pour this tea on the saucer. So students, what happens if you see the shape of the cup? Okay, suppose this is what is a cup, and we are having saucer something like this, right? So the area which this liquid gets here is lesser than the area which it gets on the saucer. Definitely consider these are some surface molecules of tea, and these are some surface molecules of a tea on the saucer. Tell me, where is the area, like where we observe the area is more? Of course on the saucer. So it becomes the evaporation rate or the ability of this evaporation of the molecules is getting faster, right? Because we are having large area than the cup. Okay, that's how eventually we say rate of evaporation is more in saucer than cup. All right. Drying of clothes, it's very daily life example, you observe it daily. What happens here if I'm having a cable and I'm having some clothes? Okay, so what do we observe here? Okay, suppose these are the pins, correct? So if we're having clothes which are wet, obviously, correct, they're not dry. So when we observe the evaporation, what we have seen that the surface molecules which are present in these wet clothes are getting what? They are getting evaporated, they are getting volatile. Okay, they are getting vanished, they are escaping themselves because of the collision which is happening between their molecules and the water molecules. Okay, are you all able to follow it? Same is observed here also, and that's why we say like drying of clothes is nothing but an example of what? Evaporation. Sweating, it is also one of the examples of what? Evaporation. Okay, which we observe in a daily life, which like the same mechanism is being observed in all of these examples. All right. Yeah, these are some images. This is what is tea. Okay, clothes and sweating. Now we need to understand the next part of evaporation is that there are some factors which are affecting the rate of evaporation. Okay, so what are those factors? First one is what? Surface area of the liquid. Second is what? Temperature. Third is humidity. D is wind speed, and E is nature of liquid. Okay, students, try to understand there are some substances in the nature, they are very faster, they will get fast volatile or they will get fast evaporated than the other. Okay, so we can say nature of liquid is going to decide the rate of evaporation. Okay, have you all observed nail paint remover, it evaporates very faster than water. Okay, so this is nothing but acetone, it has its chemical name is what? Acetone. So I'm just giving you, we need to compare between acetone and water. So if you are going to remove, if you are going to apply it on your skin, after some time you experience some cooling on your skin, right? Because what happens, I'll explain the phenomena, why the cooling happens. Okay, when the collision happens, students, these molecules are going to interchange, or they are going to give energy to each other. Suppose collision is happening and like this is pushing, this molecule is pushing to this, okay, and they are getting collide with each other. Actually they are making this particle very extra charge or very extra active. This is happening with each and every surface molecules, they are getting extra charged, they are getting what? Extra charge, and their kinetic energy is quite high. So these molecules which are present on the surface of the liquid, they are getting extra charge, they are having lots of energy in it. And the molecules which are there in the bulk or the down, or they are not of course surface molecules, these molecules are basically giving energy to the surface molecules. Okay, if this is happening because of the collision, so surface molecules are getting escaped out and they are taking the energy of the system and then they are vanishing out. So there is a decrease in the temperature, and whenever there is decrease in temperature, we feel cooling phenomena or we experience cooling. That is the reason when acetone gets evaporated, we like the sensations, whatever we feel, that cooling sensation, correct? So my point here is that the next point is what? Nature of liquid. So acetone has that tendency naturally that it gets evaporated very faster than water. So we do have different substances, we do have different liquids, they have got the rate of evaporation faster in them than the others. Okay, that is what your factor number 1. All right. Next, let's talk about the surface area. Just now we have covered about like drinking tea from a cup than drinking tea from a saucer. Okay, consider this is a saucer. Okay, Now suppose the tea which is there, or the tea molecules which are there in the cup, they are getting lesser space or lesser area than the area which is present in the saucer. Okay, more the area, more surface molecules will get generated, obviously, and that's how, if there is a more interaction, or there is a more collision happens among the different molecules, the number of molecules which are going to get escape out is going to get what? Increase, which means rate of evaporation is depend on the area which these molecules experience. More the larger the area, rate of evaporation will be more. It's that simple. Is there any doubt to anyone, students? All right. Coming towards the next phenomena, or sorry, next factor, that is what? Temperature. I'll explain this part here. Suppose we are having some liquid, okay, and if the temperature of this system is going to get increased, actually there will be more number of collisions, and because of that, energy or heat transfer is going to get faster. Because of this, these particles can what? Escape very quickly, okay, or they are going to get evaporate faster. Okay, so imagine that you all must have observed that in a sunny day, on a sunny day, we have observed that drying of clothes is getting very faster than when we are having what? Moisture in the air, correct? So that is the reason, if you are going to increase the temperature, what happens? Rate of evaporation increases. Correct? So I'll just write it here. Surface area, if area is getting increased, I'm just giving you how to write it in a very shortcut. Okay, area is increasing, evaporation is increasing. That's it. If temperature of the system or the liquid is getting increased, try to understand evaporation increases. Then let's talk about the humidity. Humidity is nothing but water content in the air at that particular temperature. Okay, suppose this is what is air, come imagine, and it has got some water molecule. Okay, so try to understand, air has its own limit to have water inside it. Okay, so its maximum water content in the air, which is nothing but humidity. And let's suppose this is the cloth, okay, and it has water molecules. Of course, it's a wet cloth. Okay. Suppose I say that in this area itself, this is air molecule. I'm just writing it here. This is air, and this is your cloth. Okay. In this area, the humidity is more. That means air is quite saturated with its water or moisture content. It's already saturated, like number of water molecules which are there in this area is quite saturated. That means there is humidity in the air. Okay, and suppose there are no extra spaces. Okay, and because of that, temperature of the system here is quite less. Then escape of molecules is also going to happen at lower speed. Okay, because there is no space in the humid area, okay, to absorb or to let in those water molecules which are present in the cloth. Okay, and that's why we say rate of evaporation falls down, or it is going to get decrease. It is going to get what? Decrease. So here I am writing, if humidity is more, evaporation is what? Lesser, or rate of evaporation is going to decrease. It's inversely proportional. Wind speed, of course, wind speed is nothing but what? As soon as we are going to increase, you must have seen when there is wind is whenever we observe wind is there, clothes are getting dried faster. This is the reason, again, like a rate of evaporation what? Increases. I'll explain this also. Imagine the same concept, or same example. This is nothing but air, correct? and these are some water molecules. These are some water molecules. When we these air molecules observe wind, okay, when this air molecules are going to observe wind, definitely this part of air is going to get shifted here or there. If the wind is coming from that side, it's definitely going to shift here. Suppose it is getting shifted here, and another air molecule is going to come and it has its own water content, okay. So this is happening with the cloth also, and that's how the escaping of this molecule is going to get increased because of the wind, okay, and evaporation rate is going to get increased. So if we are having like wind speed is higher, we observe evaporation is getting what? Increased. Evaporation is going to get increased. I hope you all are able to follow it. So surface area, if it increases, evaporation increases. Temperature, if it is increases, rate of evaporation increases. If humidity is there in the air, evaporation rate falls down, correct. Wind speed is there, like we are having, if it is increasing, basically evaporation increases. And we have covered the nature of the liquid also. It varies liquid to liquid. Alright. Is there any confusion, students? Okay, let's move ahead. Yes, there are some examples like feeling relief under fan when we perspire, water getting cooled in an earthen pot, and wearing cotton clothes in summer. Okay, that's the reason students, we wear what? Cotton clothes, right? Because the evaporation rate increases because of this phenomena. Then let's move ahead and deal with the next concept called as what? Boiling. So boiling is what? Boiling of a liquid occurs only when the vapor pressure of the liquid becomes equal to the atmospheric pressure. Okay, let me put it here in this way. Suppose we have taken this liquid and now we are going to supply some heat to these liquid molecules. Okay, these are nothing but what? Liquid molecules. After absorbing heat, kinetic energy of this is going to get increase, and they are going to transform themselves from liquid to what? Vapors. These are nothing but what? Vapors. So students, try to understand here. These vapors have this tendency that they are going to apply some pressure on the liquid molecules also. If it is a closed system, these vapors are going to apply some pressure on the liquid system. That is what we can term as what? Vapor pressure. Alright. So we are having a concept, boiling of liquid occurs only when the vapor pressure of the liquid, these are the vapors, the pressure which is applied by them, if it becomes equal to the atmospheric pressure. So this is what is atmosphere. It has got some air, and this air is going to apply some pressure. Okay, that is what atmospheric pressure, and inside it we are having vapor pressure. When this atmospheric pressure is equal to vapor pressure, or vapor pressure is equal to atmospheric, we say that boiling had happened. What we observe? Boiling of liquid had happened. Okay, so the pressure exerted by the vapor present over the liquid is known as vapor pressure. Just now we have covered that part. Okay, these are the liquids. We have supplied some heat, and they have transformed or they have shifted themselves from liquid to vapors. Now these vapors are going to supply some they are going to provide some pressure. That is what we called as what? Vapor pressure. And when this vapor pressure is equivalent to or it's equal to the atmospheric pressure, that time we say boiling had happened. All right. So this is what is a picture of boiling. Now here is the very important part of this session, that is what? Difference between evaporation and boiling. Students, in boiling what happens? If I am taking a substance which is in liquid state, I am going to supply some heat to the system. This is a liquid. So here external heat is getting supplied, where in evaporation, this is a cloth, okay. So it is going to dry up, it is going to get volatile very naturally. I do not supply any external heat source, okay. So it happens naturally, or for evaporation to make it happen, we don't have to supply any external source of heat, correct, unlike boiling. So that's why we say it's a spontaneous process, it happens very naturally, okay, and whereas non-boiling is non-spontaneous process, okay. Takes place at any temperature below boiling point. these are some liquids, students try to understand, these are some liquid molecules or water molecules, and evaporation happens, or the transformation of these liquids into vapors happens before water reaches up to its boiling temperature, okay, or boiling point. So it happens very naturally, and the temperature is like, it happens at a given temperature without reaching up to its maximum boiling temperature. That's very important property of evaporation. Whereas when we say, when we talk about boiling, it happens or it occurs at a particular temperature. Suppose if this is water, I am going to supply some heat to the water molecules. Students, this is again a bulk phenomena, okay. So heat energy is going to get what? Transformed throughout the system in a container, and each and every water molecule is going to boil when vapor pressure of this liquid is going to get equal to the atmospheric pressure. That time, because of the external heat supply, molecule is going to get what? Boil. That time we say boiling had happened. And if you are going to put thermometer in such solution, this is going to give you a constant temperature. Suppose in case of water, the boiling temperature is what? 100 degrees Celsius, correct? At 100 degrees Celsius, each and every molecule which is there in the system is going to get boiled, okay. It is happening because you have supplied some external heat to the system. Are you all able to understand this? Okay, here we have achieved its boiling point by supplying the heat, but here the molecules are getting escaped at the room temperature. Alright. Next is surface phenomena. I have explained about this. And bulk phenomena, it's happening in the bulk. Okay, here surface or layer by layer, the layers are getting exposed to the surrounding, and now the layer is like a role of that layer is nothing but surface molecules, okay. So each and every layer is getting transformed, or it is surface for the environment, okay. Suppose this is layer number 1, it is getting vanished or it is getting evaporated. Next layer to that is become what? Surface molecule. If it is getting evaporated, next layer is becoming surface layer. Likewise, it's happening, or it's happening like it's a surface phenomena. Whereas in boiling, in the bulk, molecules are getting what? Boiled off at a particular temperature. Yeah. Can you all see it? See, these are surface molecules, and spontaneously, naturally, they are getting escape out. Can you all see? Each and every molecule is leaving the surface. But here, in bulk, all the molecules, when we supply the heat, are getting extra charge, extra activated. Kinetic energy of this molecule is very high, and they are living there, boiling themselves at a particular temperature. Alright, let's move ahead. So here, any activity or process when occurs on with all surface particles, because particles with high kinetic energy in comparison to others come on the surface to form a surface layer, is known as what? Surface phenomena. Alright. So here, suppose this is what, I will just explain it again. These are the molecules, okay. And we know that continuously collision is going to happen, and because of that, the extra charge or extra activated particles are going to form what? Surface for this system, and they are going to get evaporated naturally. When it happens, when we observe such kind of thing, we say that surface, this is surface phenomena, correct. Next to that, an activity or process which occurs to the most of the particles of matter at a time is called as bulk phenomena. In boiling, when we observe, each and every molecule which is there in the system is getting activated. Kinetic energy of these molecules is getting increased in a bulk, and that's why escaping is happening in a bulk. That's why we say it's a bulk phenomena. Alright. Next, we are having melting point. Students, again, it is also same like boiling, or like here we are having solids, okay. Consider this is ice, alright. And if you are going to supply ice which is solid, you are going to melt this ice, and the temperature at which each and every ice particle or ice cube is going to get melt out completely, that point can be considered as a melting point. Again, so the minimum temperature at which a solid melts to become liquid at the atmospheric pressure is known as what? Melting point. If you are going to supply heat, and suppose you have kept thermometer in this, students, each and every particle is going to get what? Energized, or heat energy is going to transform. Okay, there will be a point in this that the intermolecular spaces are going to get increased. Okay, that means from solid, the shift is happening from solid to liquid. And if this is happening at, definitely it is going, the melting is going to happening at a specific minimum temperature. Okay, and that's the temperature where we observe the system is melted. Each and every molecule of solid is melted into, or they are in the liquid state. That is what melting is, correct? So here they have shown like, see, the temperature is 0 degrees Celsius and now melting had happened, okay, at 100 degrees Celsius. Then latent heat of fusion, the heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. It never happens like if I am having, see, fusion, that means bond is getting fused or solid is getting converted into liquid state, correct? So it never happens that you have kept solid particles or like you are supplying heat to those particles and instantly they are melted. Have you all observed that? Like, does it did it happen in that way? I think no. Why? Because these particles are going to absorb some energy. Okay, I'll explain it in better way, students. Suppose these are some molecules and we are supplying heat to them. Okay, this heat has two motto. First is that what? To increase the kinetic energy of the system. Okay, so it is going to increase, it is going to make each and every particle or molecule in the system, they are going to get extra charge, their kinetic energy, the ability to move here and there is going to get increased. Okay, so that means kinetic energy is going to increase. Secondly, that with the help of this heat, like what's the role of this heat? It is that, suppose it's a proper arrangement of all those molecules, students, and they are all extra charge. Next step to that, to fuse the bond which is present them. Okay, now there will be fusion or breakdown of the bonds which is there in the system. Okay, firstly they are going to get extra charge and now still we are going to continue with the supply of heat. Now what do you mean by that supply? Like, what is the role of that extra supply of heat? It is going to fuse the bonds which are there in the particles, and that's why there will be more spaces between or among these particles, and that's how the shift is happening from solid to liquid. Okay, so now I told you initially these particles are going to get absorb some energy. So here the heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure. So how much energy did they require? How much heat energy did they require? Here the emphasize on the word 1 kilogram of solid. Okay, so how much energy did those particles need to convert from 1 kg of solid to liquid? That energy is called as what? Latent heat of fusion. Latent word has the meaning, students, hidden. So what happens? This is hidden. Why are we saying hidden? Because if you are going to put thermometer in this type of experiment, you are not able to see, such as suppose if I'm having a thermometer, I am supplying some heat to the system. It's a solid, it's a 1 kg of solid. Okay, and I saw that there is an increase in the thermometer, the range or the temperature is getting increased, correct? But after some time I observe the temperature which is there in the on the thermometer scale is not getting increased. I maybe I will think that is my thermometer is not working good, or though I haven't cut off or I didn't put off the flame, still my thermometer is not going to show me, it's not going to read the temperature or the heat. Why it happens? It is not like that we are not supplying the heat. We are supplying the heat, but still thermometer is not showing any temperature, because students, that extra heat is getting utilized. The extra heat, I told you there are two purposes of supply of this heat. One is like to increase the kinetic energy, and second is to fuse the bonds, and that's why the fusion is going to happen. Shift is going to happen from solid to liquid. That temperature range or the extra heat which temperature thermometer couldn't read is quite hidden, because each and every molecule is getting extra charge and there is a fuse of these bonds. Okay, so that is what latent heat of energy. Once each and every molecule is going to like if when we are observing that fusion had happened, the bond has broken down, that time suddenly we observe each and every molecule is in liquid state. Okay, and then our thermometer is going to show the temperature. Are you all able to understand? Because boiling melting had happened completely. Okay, but to fulfill the second purpose, we don't see any change in the reading of thermometer, because it's hidden. Thermometer can't even read the amount of heat which we are supplying after some time. Okay, that is what hidden energy, hidden or latent heat of fusion. So, boiling point, when a liquid is heated, its vapor pressure gradually increases. Of course, when the vapor pressure equals the atmospheric pressure, the liquid begins to boil. The complete boiling happens when the vapor pressure is going to get equivalent or it's equal to the atmospheric pressure. The temperature at which boiling occurs is called as what? The boiling point of the liquid. It is same as just now we have understood about melting point, students. So these are the liquids. They are going to get what? Vaporized. Okay, they are in the what? Vapor state, and we know that it is surrounded by some air molecules, and these air molecules are going to get what? Supply some pressure. That is what? Atmospheric pressure. Suppose there are so many water molecules. Okay, and these are the vapors which are going to supply vapor pressure. When vapor pressure is equal to atmospheric pressure which is supplied by these air molecules, that time boiling happens, correct? But when are we going to note down the boiling point? When each and every molecule, liquid molecule, is going to get what? Completely boiled off. That time we are going to measure the boiling point of any liquid. Okay, so the temperature at which boiling occurs is called as the boiling point of the liquid. Then latent heat of vaporization. So here the heat energy required to change 1 kilogram of liquid into a gas at atmospheric pressure at its boiling point is called the latent heat of vaporization. It is again same, students, here. So these are the water molecules or liquid molecules, correct? We are supplying heat. The molecules are extra charged because kinetic energy has increased. That time our temperature is going to rise up, but it is going to stuck at some time. Okay, because the role, I told you there are two roles of this heat. One, to increase the kinetic energy, and second, what? To make the liquid boil. Okay, so to make the liquid boil, as in what? Each and every liquid molecule needs some energy, and heat is supplying that energy which is hidden. Our thermometer is not going to read that temperature. As soon as each and every molecule is charged up and it's boiled completely, it is going to show you change in its temperature reading. So we can say that at 100 degrees Celsius, water is getting boiled. Okay, why? Because the temperature at which boiling occurs is called as the boiling point. Here vapor pressure is like the vapor, this is the vapor pressure, these are the vapors. The pressure applied by this vapor is what? Vapor pressure. When it is equal to the atmospheric pressure, we say that system is boiled, liquid is boiled. Okay, but our thermometer couldn't read that extra heat, which is nothing but what? Latent heat of vaporization. And the heat energy which is required to change 1 kg of liquid to gas at atmospheric pressure, that time we can say it is nothing but latent heat of vaporization. Here we are forming vapors, correct? And that's why the word is vaporization. All right. So we are having freezing point, the temperature at which all the particles of liquid start solidifying. Okay, so here we are having liquid, and definitely these molecules are going to freeze down to convert themselves as what? Solids. And change to solid state is known as what? Freezing point. We have seen, like, first was from solid to liquid. Student, that was melting, correct? Now from liquid we have seen the vapors or the gaseous state of the substance, that was boiling. Thirdly, definitely when we are having liquids, how do they get solidify? They are going to get solidify on freezing, correct? So that is all about the point at which, or the temperature at which all the liquid particles are going to solidify themselves can be termed as what? Freezing point of the matter. Alright. So here is the representation for the same. But here, instead of supplying heat, the way we have supplied heat in melting or boiling, here we are going to cool down the system. The molecules are going to come closer to each other, and that's why solidification is going to happen, and that's why we say liquid, like water which is liquid is going to get converted into what? Ice, correct, which is nothing but a solid state. And at what temperature it happens? 0 degrees Celsius. Got it? Freezing of water to ice. All right. So yeah, students, that was all about for the session. We have covered very important phenomena such as what? Evaporation. Then we talked about factors which are like affecting the rate of evaporation. We covered all about boiling, melting and freezing. Apart from that, we have covered very important two concepts such as what? Latent heat of vaporization and latent heat of fusion. Is there any doubt? Is there any confusion, students? Because from your Olympiad exam point of view, these are very, very important topics. Okay, so emphasize on these topics while studying for the exam. All right. So that was all for the sessions today. Sessions student. We'll meet you next time. Till then, bye bye. Take care.